Now we talked about these next hop addresses at the end of the previous video and why this happens, and I'm actually going to tell you why it happens in the next video. And I know you're already thinking, the next video, why can't you just tell me on this one? I want to introduce you to a command here that'll change things for us a little bit called next hop self. And what we're going to do is change the next hop of a couple of these routes on router 1, but we're not going to use the next hop self command on router 1. We're going to use it on router 2, and you'll see why in a moment. I know there's a lot of, what? Here's how we do this, or why we do it here. Let's use iOS help to take a look at the next hop self command. And using my mastery of the alphabet, I can see that all the commands that begin with N here, there is no next hop self command. The reason we have to go down to router 2 to use next hop self is that it's an option with the neighbor command. Oh, that's why he went down there. So of course we're going to put 172.12.123.1, and there's a next hop unchanged. We're not going to use that one. What we want is next hop self. And sliding that over just a bit, you'll see disable the next hop calculation for this neighbor. Sounds pretty serious. And I know we haven't quite gotten to what that next hop calculation is, but as you'll see, I need to show you this command before we move on to that particular calculation. So let's go ahead and finish this up. Next hop self and create. Now we need to do some kind of update here because this is not really considered a route change by BGP. So we're going to do what we call a soft reset. And I will go over all of these in a separate video later because there are ways you can clear BGP and actually you end up tearing the adjacencies down. And that's the way we had to do it back in the days of the dinosaur. Now we have what we call a soft reset where it updates everything without tearing your BGP adjacencies down. Always a good choice. So let's go back up to router 1. Let's go up to router 1. There we go. I knew we could do it. And let's take a look at these routes now. And there's quite a difference here. First off, you'll notice those 234 entries from subnet 234, they're gone. 172.12.234. And they've both had their next hop change to 123.2. Also note that the route selection for router 4 has changed. Instead of using the path going through 172.12.123.3, it's using the path going through 172.12.123.2. Now, router 3 didn't change, so let's see what's going on there. The good thing here, though, is you'll notice the word inaccessible is gone. So even though the primary path selection for a 3333 was not changed, we no longer have an inaccessible backup. Where if we go with show IP BGP 4444, gives us a little more information. Of course, we're not going to see external there, inaccessible there either. Let's go back to the board because I want to show you these and also why that changed. Why did the path for 4444 change, the next hop that is, where the path for 3333 did not? And there's the table. And here we go. These are the two tables we just looked at for show IP BGP. Now at the top you see show IP BGP 4444. The reason that path is now in use is its AS path is shorter than the other valid path. And you can see that if you look in there, you'll see 300, 400 for the first path, and then 400 for the next one. Let me show you that on the live equipment. It's a little easier to highlight. Here are your AS paths. And that's why I love show IP BGP and then following it with the network. And there we go. So all of a sudden, this previously inaccessible path had a shorter AS path that ended up being the tiebreaker that mattered. So this path was the one that was chosen. Now let's go up here to 3333 and you'll notice that the AS path was exactly the same length. So something else, something else had to be the difference maker there. And that's because the best path selection process was just a little longer for the 3333 network because the weights are the same, the local pref was the same, none of the routes originate on router 1, the AS path length is the same, the origin code is the same, the med, which is the metric, that's the same, it's 0. So finally we get down to eBGP routes being preferred over IBGP routes, and that's why the path of the next hop of .3 was chosen as the best path external over internal. And that's why you just got to have that list down cold, the BGP best path selection process, because sooner or later you're going to start getting to that 7th or 8th tiebreaker. Now, we're going to go back to the original next hop addresses, and it never hurts to do a little removal here. So, usually, almost always, as I like to say, well, we need to get into 2 to take that off anyway. Thought you had me. I'll just use up to repeat my commands, and then a Control A to move to the front, and just put a no in front of it. 99 out of 100 times, that'll negate a Cisco command for you. Every once in a while, you bump into one where you can't just put no in front of it. So I'll do a clear IP BGP soft out. And let's go back up to router 1. And you can see we're back with the original next hops. You can see the 234.3 and 234.4 entries are back in, and also the path selection for both of them is going through 123.3. So things are back to where they were before we did this video, and that's actually a good thing, because I wanted to show you that command now before we got to that, as the router called it, the next hop calculation, because that's what we're going to look at next. Because again, we had, let me bring that back up, just want to review this. You know, both routes are going to router 1 from 172.12.123.2. But we've seen that when the routes get to router 1, they have the next hops of 234.3 and 234.4, which were the next hop addresses when router 2 received them. So why didn't the next hop addresses change? Why did we even have to do next hop self, right? Well, you're going to find out in the very next video. I'll see you there.